All right, so this next topic is basically a continuation of resonance structures, and it's bond order. Bond order is just the number of bonds between two atoms. So for example, when we drew our chlorines, our Cl2, we have a bond order of 1 because we have a single bond between the two. When we drew our oxygen, our O2, we drew a double bond, so the bond order is 2. And then when we drew our nitrogen, our N2, we drew a triple bond, so the bond order is 3, right? 1 is single bond, 2 is double bond, 3 is triple bond. Makes sense. Now, what about when we consider our compounds that have resonance structures, right? So again, our nitrite, remember that we said experimentally, both of these two bonds are exactly the same, right? So they must have the same bond order. So what is that bond order? What is this bond? We can see it's not a single bond, and we can see it's not a double bond. So it's somewhere in between. So the bond order can be calculated a number of different ways, but one of them is to take the number of bonds and then divide by the number of resonance structures. So for example, you would take a look at only one nitrogen-oxygen bond. So here's one bond, and then here's two bonds. 1 plus 2 is 3. So we have 3 total bonds between that nitrogen and that oxygen. And then we have 1, 2 resonance structures. So divide by 2, and then we get 1.5, right? And that makes total sense. Since these are equally good, this resonance structure shows 1 bond, this one shows 2. If you think about the average there, it's 1.5. So even though we draw it like this, we understand that it's really more that delocalized picture where our bond order here is 1.5. Let's do another example, carbonate. And if you're getting tired of showing all these dots, once you take OChem, we can stop showing them. But for now, we're in Gen Chem, so we've got to show all of these dots. So carbonate has 3 resonance structures. And if you think about these 3 resonance structures, they're all equally good. Every atom here has a filled octet, so that's awesome. And then the formal charges are as low as possible, where we have a negative charge on 2 of the 3 oxygens in each one of them. So if we think about what the bond order here is, and again, you can calculate this mathematically, or you can just kind of think about it logically. We're just going to take a look at one of the carbon-oxygen bonds. Here we have a double bond, here we have a single bond, and then yet another single bond. So 2 plus 1 plus 1 is 4. And that's across 1, 2, 3 resonance structures. So we divide by 3. And so we can tell in the real structure, all 3 of these bonds are the same, and they all have a bond order of 1.33, or 1 1/3 of a bond. And same thing with charges, right? Note that this has a negative charge here, a neutral charge here, and then a negative charge here. If you were to find the average, on average, it's a negative 2/3 charge. So in the real structure, each oxygen has a negative 2/3 formal charge, and each bond is 1 1/3.